So objects falling under gravitational acceleration, or just objects falling under gravity, is a special example of one-dimensional motion. It's anything that is related to when you just drop things like this, or when you chuck something in the air, and things like that. And this will be foundation to something called projectile motion that you will definitely study in kinematics in 2 dimensions. So if you want to understand that one, it's a good video to look at. Now, what happened in between 1589 and 1592 is Galileo um, was a scientist, and he went on top of the Leaning Tower of Pisa in Italy, and he dropped a couple of objects which had the same volume, but their masses were different. One was heavier, not happier. One was heavier, and the other one was a lighter object. What happened was that both of them, they reached to the ground at the same time. Okay, so this is how the story goes, and this confirmed, well, at least indicated with a reasonable degree of certainty, that two objects near the surface of the earth, they have the same acceleration when they're falling towards the earth. So that acceleration is has a value, has an average value that is important, and that is equal to 9.81 meter per second square. I said average because it really depends on where you are on the surface of the earth, because earth, when it rotates, it has rotational effects, and it might have air resistance when the body is falling, and depending upon if you're a north pole or equator, or where you are, your longitude and latitude, that all come into factor when you really want to calculate that value of G. But for all purposes in this course, G equals to 9.81 meter per second square when the air resistance is negligible, or if there's no air resistance. So we're going to be using G equals 9.81 meter per second square. Now, to solve equations related to one-dimensional freely falling objects, we need to first understand that we have to attach a coordinate system to our problem. What that means is that we have to just keep in our minds that there's a coordinate system here, and it's going to be this one. Now that x-axis is redundant, because what is happening is we're discussing the objects which is going up like this, or coming from up to down like this, something like that is happening. So entire motion of this object is in the y direction, but for the sake of completeness, let's also include a horizontal direction, and let's call that x. So positive x is this side, so negative axis will be here, and negative y will be here. Now what we do is we have got coordinate system here. Now let's also have the equations of motion. So equations of motion. Generally speaking, you must be familiar with this, that final velocity is equals to the initial velocity plus acceleration times time. Final position is equals to initial position plus initial velocity times time plus half acceleration time squared, and final velocity squared is equals to initial velocity square plus 2 times acceleration times final position minus initial position. So these are called kinematic equations, and these equations, like, you just plug in value, like if, for example, if you want to solve this one, and if you want to figure out what T is, you need to know what V naught, V, and A is. Just like any other equations, if you know everything else other than the thing that you need to find, you can find that by just solving these equations. Now what happens in one-dimensional freely falling objects is that instead of acceleration A and acceleration A, what you have is acceleration equal to minus G meters per second square, or acceleration equals to minus 9.8 meter per second square. Now that is because of our coordinate system. That is the only reason for that, for that to take into account, for that minus to be in front of 9.8 meter per second, and that is this coordinate system. So if you have that coordinate system, you can rewrite these equations as, let's say, equations will be the same, okay, but there will be a difference, and the difference will be a will be equal to minus g. So for 1D freely falling objects, actually it's not just 1D. Whenever there will be freely falling objects, or when you have taken this coordinate system to be plus y in the upper direction and then minus y to be downward direction, then you will always have this, and a will be equal to minus g. That means I just erase wherever a is with the sign and I use minus g. So that will be minus half gt square, and this will be minus 2g x minus x naught. And there will be one other difference. Instead of x we have y, and instead of x naught we have y naught. So that means here I need to change the variables from y to y naught. Right, so these are how the equations are modified in one-dimensional freely falling object under the influence of gravity.